Thank you so much again for organizing this event and for inviting us to be here. Super happy to be here today. My name is Luna from Genecis Bio. And what we do at Genecis is quite simple. We make biodegradable plastics from organic waste. Last year, over 300 million tons of plastics were wasted, causing massive global pollution. At Genecis, we know that there's a better solution. It's a material made by bacteria called PHAs, or polyhydroxyalkanoids. And PHAs can replace 60% of the world's petroleum plastics. That's really cool. And that's because PHAs are fully biodegradable and it's got great performance. And at Genecis, we make PHAs affordable by producing them from cost-negative food waste as opposed to expensive sugars. That's our core value proposition. We're able to make PHAs at negative 40% cost than most of our competitors out there. And of course, we're not going to stop there. At Genecis, our vision is to become the standard oil of food waste. Now, roughly 100-something years ago, John D. Rockefeller founded Standard Oil to convert or refine crude oil into kerosene, which is a chemical that was used back in the days to light up oil lamps. Now, what most people may not know is that during the manufacturing of kerosene, a huge amount of waste materials was produced. And this waste material was petroleum. Now, then Standard Oil went on to seize the opportunity to refine this waste material, petroleum, into the many products that we're all very familiar with today, including gasoline, fuels, and of course, plastics. So at Genecis, we believe the same could be done with food waste by transforming them via biotechnology and bacteria into sustainable materials of tomorrow, starting with PHAs. And this is all made possible with our perfection of the bacteria. In the last couple of years, we partnered up with nature to sequence over 1,000 novel bacteria species and select for the best genes. Earlier this year, we successfully integrated them into a single organism, creating the world's first recombinant bacteria, capable of converting mixed food waste into tunable PHA polymers. And together with our multiple lock and key systems, which includes data-driven algorithms and process innovation patents, we have built a strong moat around our core technology. And in terms of penetrating the market, we're first starting with flexible PHAs, because flexible PHAs are actually very difficult to make from pure sugar feedstocks. And they currently retail at 5 to 7 times higher price point than rigid PHAs do. But at Genecis, we could actually make both rigid and flexible PHAs by tuning our bacteria content at the same cost using food waste. And that gives us a huge unique advantage, this ultra premium market. That's exactly where we want to start with our go-to-market strategy. We've essentially adopted a go-to-market strategy that's similar to Tesla's, starting with the ultra-premium market where we can create high margins, low volumes, using then the profits of that to broaden our market scope and make PHAs even more affordable, whereby eventually we can unlock our ultimate goal, which is unlocking the massive $500 billion commodity plastics market. Now, I know what you're thinking. It probably sounds like a dream. It's a very long way to go, and many companies have tried to do this, but fail. And all for good reason, by the way. So in the bioplastic or the biotechnology industry in general, typically speaking, if you want to have a large production plant, it costs up to hundreds of millions of dollars and up to 5 years to set up a single production plant, right? At Genecis, we're not doing that. We have a very unique approach to scaling up our technology. We will instead piggyback our technology onto the existing infrastructure biogas plants, who already have very similar equipment, process, technology, and permits that we need. And this model really allows Genecis to scale 5 times faster than a fraction of the costs. And for biogas plants, we help them generate a product that is 10x the revenue that they would otherwise get from making just biogas. And of course, this is no longer just a pipe dream. Last couple of months ago, we've actually been approved of a $6 million project from the Canadian government, Engine, to integrate our technology with one of the largest biogas plants here in Canada, Stormfisher. On the other hand, our customers also loves our product. In the last 12 months alone, We've went from $0 in revenue, pre-revenue, to closing now over $1 million in product development fees with Fortune 500, paired with $10 million in purchase orders. And that really sets us apart from many of our competitors who have been around for the past decade, but are still nowhere near product launch. A lot of these Fortune 500s that we're working with right now actually already have millions of units of products on the market today that we will be replacing. And actually, that's why I'm here currently in Denmark, in Copenhagen, Denmark, working with one of our newest clients, Novo Nordisk, where we're actually going to be converting their insulin production waste into plastic components that will then go into their insulin pen devices. And Novo Nordisk is the largest insulin producer in the world. And this is one project that we're super excited about, and you'll be hearing a lot more about in the news coming up. And that actually gets to our current biggest challenge right now. Our biggest challenge is that in the last couple of months alone, we've secured these $10 million in purchase orders, plus a lot more customers on the wait list that we cannot serve. So currently, as of right now, we're actually completely sold out in terms of our existing capacity for the next 3 years. And that's been one of our biggest challenges, especially now being able to hit a lot of the key technical milestones with our existing JDA customers, whereby the number one common questions that we're getting from our clients today is, how can we make polymers faster? And that's what we've actually spent the last 2 months really trying to figure out internally. And it turns out, ironically, that we actually had the answer in front of our eyes all along. It's a common practice in the plastic industry called compounding, which is really just blending your own resins with other market resins to form these composite resins that can still meet all the technical specs required by your client. But doing this actually gives us two major benefits. Number one is that it really removes the bottleneck that we had internally in our productions. So we're no longer limited by how much we can produce ourselves, as we can supplement the overall resins with market resins. And number two is that it actually heavily de-risks our customer supply chain, especially when it's working with a new startup like us, being able to actually get polymers faster, cheaper, and having a more secure feedstock or more secure supply chain. It makes our customers really happy as well. So this is a new strategy that we've essentially embarked upon, and that we really believe will help us unlock our $10 million of purchase orders as early as next year. And what's our secret sauce? An award-winning team. My COO and I have both built profitable companies in the past. And our CFO co-founded a $300 million bioplastic company that is one of the largest in the world today, NatureWorks, which spun out of Cargill Dow. Our directors have decades of experience in scaling up technology, as well as working in big companies, including Honeywell. And also our team of 25 engineers and scientists has won many awards, including first place in the Quebec Engineering Competition and the 2019's LTech Young Scientist Award. In terms of progress, we are unrecognizable from when we first started back in 2017. Back then, we really didn't have much more beyond just our passion, so we couldn't afford expensive bioreactors, and we ended up having to build them ourselves out of rice cookers. Fast forward to today, we now have a 7,000 square foot pilot facility equipped with state-of-the-art equipment, and also achieved industrial scale validation with the National Research Council of Canada. We've also been able to raise over $11 million to date, 3.5 of which from notable investors like Y Combinator, paired with $7.5 million in non-dilutive money from the government, whereby we were one of the youngest teams in Canada to be awarded a multi-million-dollar industrial scale-up grant. And that's all about Genecis. And the reason why we're here today in our main ask is that we were actually raising a roughly $10 million Series A couple months ago, but recently, just a couple of weeks ago, a lot of our existing investors, as well as investors that wanted to put money into our company right away, so that we can take that money, really use it towards our compounding strategy, so we can start fulfilling our purchase orders as quickly as possible. So we've actually decided to open up a no more than $2 million bridge round, really quick, rapid round, which we started just last week. Now it's actually almost 80% filled. We'll be closing next week. If any of you guys are interested, please do contact me by the end of this presentation. Thank you again for your time. And yeah, thank you so much again, Brian, for organizing this event.
Just no problem at all. And seeing the rice cooker reactor picture again, the last time I saw that was, I think, in the Green Centers Canada pitch. So that was worth it alone. Thank you very much.